All right, here we are on the first video of our series. I watched the intro yesterday, so you kind of know what's going on here. Notice I'm using the blue marker today. Probably ask you about the blue marker tomorrow when you come into class. A couple other things you'll see along the way. Big idea we're going to talk about today is the distributive property and how to use the distributive property to simplify some expressions in algebra. This is a skill that you should have seen before, and we've talked about it in some spots. But really want to make sure you have a good grasp on it before we start to get into the new thing, which is dealing with quadratic equations, solving quadratic equations, finding x-intercepts of quadratic equations. You really need a good grasp on the distributive property. So got an example here in blue to get us started. It's 5 times the quantity x plus 2. Hopefully you recognize that this is a problem that we can simplify using the distributive property. We're going to multiply that 5 through the parentheses. We're going to do 5 times x. And give us 5x, and then 5 times a positive 2 give us 5x plus 10. We've got that simplified, right? And that's what the distributive property is all about. Doesn't matter if you have a number outside of these parentheses or if you have a variable. You know, like for example, we could have x out there, maybe x times the quantity of x minus 3. And we're still going to use the distributive property and multiply the x through. X times x, be x squared. Multiplying that. X times a negative 3 gives us x squared minus 3x for an answer. Okay? You could have both a number and a variable out there. You could have a term that has both. You know, maybe something like 5x times the quantity x plus 4. Still distributing that 5x through there, multiplying 5x times x, get you 5x squared, and then 5x times a positive 4. 5 times 4 is 20, so we have plus 20x there. That's how we do the distributive property. You can have more than one variable in a distributive property question. You can have something like 3x times the quantity, 6x, minus 5y. All right? Why don't you go ahead and take a second, pause that, see if you can do that on your own. All right, while you pause that, I put my UK hat on to do the rest of this problem. We're going to multiply 3x times a 6x. 3 times 6 is 18. And then x times x, you've got another x squared. Now when we distribute with two different variables, like we do 3x times a negative 5y here, we're still doing 3 times a negative 5. That's going to be a negative 15. You have an x and a y, you just put both variables. X, y, like x times y. Technically you can put y, x, you'll probably see alphabetical order. You'll probably see x, y instead of y, x for the most part. So same idea with the distributive property there. Okay? So now that we've seen the distributive property question and some examples of that, I want to talk about how we multiply two things that are what we call binomials. Binomial, remember, we have two terms in each of our expressions. So x plus 5 times x plus 3. Now the thing I want to stress here is that what we're doing here is still the distributive property. It's got a special name that you might know that I'll mention here in a second. But we're still doing the distributive property. It's just that we have two terms now in that binomial. We have that x and we have the positive 5. So what we want to do is we want to distribute each of those terms. We want to do x times x and x times a positive 3. Right? Just ignoring that other plus 5 for a second. X times x would give us x squared. X times a positive 3 would give us plus 3x. All right? Now, let's look at that other term. Let's look at that plus 5. Now we're going to take that positive 5 and we're going to use the distributive property there. We're going to do 5 times the x. It's a positive 5x. And then 5 times 3, we've got a positive 15. Right? And what you'll notice is that we have two terms that are like terms that we can combine there. we have a 3x and a 5x. A positive 3x, a positive 5x would combine to give us an 8x. And so our answer, our simplified answer there, would be x squared plus 8x plus 15. Now you may be familiar with something called FOIL, and that's the process that we've done there. FOIL is a way to remember how to multiply binomials. Stands for first, outer, inner, and last. So you remember what you're multiplying together. You're multiplying the first terms of each thing together. X times x, you got an x squared. You're multiplying the outer terms, the x times the positive 3, and that's where that plus 3x comes from. The inner, you've got a 5 times an x, plus 5x. And then for the last term in each of these, positive 5 times positive 3, you get the plus 15. So that's where the FOIL idea comes in. And FOIL's a fine thing to remember. Just remember, all you're doing is the distributive property still. You're not really learning a trick or anything to multiply those. You're simply doing the distributive property 2 times. 1 time for the x, 1 time for the plus 3. Okay? So that's how we do the distributive property with binomials with 2 terms, multiplying them together. Okay? So now that you've seen that example, well, let's look at a different one. Get the blue marker back out here. Say x minus 7 times x plus 4. All right? If you feel like you're comfortable trying that, go ahead and pause it and try that. I'll go ahead and go over the answer here. We're again doing the distributive property. We're multiplying the first terms together. We're doing the x times the x. That's an x squared. All right? Then x times a positive 4 plus 4x. That's just the distributive property. You may think of it as multiplying the first terms together and then multiplying the outer terms together. X times a positive 4. All right? Next, take your negative 7. Do the distributive property here. Negative 7 times x. Those are the inner terms, or the ones on the inside. And negative 7 times a positive 4 is a negative 28. That's the last term in each of your parentheses, in each of your what we'll call factors later on. Again, look for like terms that combine. Here we have a positive 4x and a negative 7x. Be careful of your signs there. Those are going to combine to give you a negative 3x in the middle. We still have x squared. We still have a minus 28. So our answer there is going to look like x squared minus 3x minus 28. You'll recognize that now as looking like a quadratic expression. It's got that x squared in there as the largest exponent, what we call the degree. All right, so that's how we multiply those 2 things. I want to show you a couple of other examples that might seem like they look a little bit different to you, but they're the same type of problem. One's just kind of a notation issue. If you see something that looks like that, x minus 5, that quantity squared. So a real common place that people will mess up, because what people want to do is just do x squared and then just do 5 squared. But by doing that, you forget about some of the terms. Remember that squaring something means multiplying something by itself. So if I want to do x minus 5, if I want that whole quantity times itself, right, that's like having x minus 5 times itself. Like that. Right? Just like having x minus 5 times x minus 5. So we're doing a distributive property again, or we're doing that FOIL process. X times x, x squared. X times a negative 5, and then a negative 5 times x. And finally, be careful of signs again, negative 5 times negative 5 gives you a plus 25. Combine your like terms. Still x squared out front minus 10x in the middle, and then plus 25. Right? That's what your final answer is going to look like. So remember, having a quantity squared like that is that quantity times itself. You're still doing FOIL, you're still doing the distributive property. Once again, last thing I want to show you is doesn't matter if you've got more than one variable here. We've got an expression that has both an x and a y, or two other variables. Doesn't change how you do the problem. So back to the blue marker, and I've got 2x minus 5y times 3x plus 4y. All right, again, two binomials. Each one of these parentheses has two terms in it. We're going to do the distributive property. We're going to do the FOIL process again. 2x times a 3x. Those are my first terms that I'm multiplying together. 6x squared. All right. Then if I do 2x times 4y, still a distributive property, the outer terms, 2 times 4. Remember, if I've got x times y, I'm just going to make it 8xy. Inner terms, negative 5y times 3x. It's going to be a negative 15. And y times x, you'll save yourself some trouble if you go ahead and make that xy. Go ahead and put those in alphabetical order. You'll notice the like terms combine a little bit more easily, I think, if you do it that way. And then finally, negative 5y times a positive 4y. We've got negative 20. And then y squared. Combine my like terms. Still 6x squared there. These are like terms. They have the same variable. So 8xy minus 15xy is a negative 7xy. And then minus 20y squared. All right? That's how it's done. And again, the big idea here is the distributive property is the exact same whether you've got one term you're multiplying through the parentheses or whether you've got two terms you're multiplying through the parentheses. That FOIL process, it's just a distributive property again. Yes, I'm holding a tennis ball, but it's just the FOIL and the distributive property are the exact same thing. That's the big idea for the day. That's a skill that's really important. Make sure you know how to do that. We'll talk about that and work some practice problems in class tomorrow. So, see you tomorrow.